This is Bill Farmer again. Welcome back to Software Engineering 2FA3, Discrete Mathematics with Applications 2. Today we're going to complete the topic of push-down automata and context-free languages. We're going to begin with another kind of automata, the deterministic push-down automaton, DPDA. Now this is similar to a non-deterministic push-down automaton, except exactly one transition applies to each configuration. So it's a truly deterministic machine. You can see lecture F in Cozen's book, Automata and Computability, for the details. A deterministic context-free language is any language accepted by a deterministic push-down automaton. I'm going to write a Theorem 12, and this theorem says that every deterministic context-free language is a context-free language, but not every context-free language is a deterministic context-free language. And so in other words, non-deterministic push-down automata, they accept a bigger class of languages than deterministic push-down automata. And Theorem 13 says that deterministic context-free languages are closed under complement. You remember last time we mentioned that context-free languages are not closed under complement. And here is an example, right here, L is an example of a context-free language that is not a deterministic context-free language. I should say not L. L is this language. It's the language of a string followed by itself. It's the language of all strings constructed by a string followed by itself. This language, interesting enough, is not context-free. You can go to Cozen's book and see why that is, but the complement of this language is context-free. And so what that tells us is this complement is context-free, but it cannot be deterministic context-free. And that's because if it were, by Theorem 13, that would mean that L would have to be context-free, and we know L is not context-free. So we're going to end by looking at some applications and a summary. So let's L be a programming language. And we can say a parser for a programming language is a program that takes a program in this language as input and returns a parse tree of the program. And this parse tree basically shows the syntactic structure of the program. And the parser will reject the program if it has syntactic errors. So basically what this parser is doing is it's recognizing what strings are programs in the language, and it's also, when it does recognize that a string is a program, it constructs a parse tree. And these parse trees are very important because they're used for things like producing or they're the first part of a compiler. You take the parse tree and you translate that to another kind of programming language. So if we had a compiler for a language, the parser would be what would be called after the lexical analyzer. Remember, the lexical analyzer takes our program and it rewrites it as a sequence, it changes it from a sequence of symbols to a sequence of tokens. Now the interesting thing is, if L is a deterministic context-free language, which is very common, and its syntax is specified by a context-free grammar, then a parser for L can usually be implemented as a deterministic push-down automaton. And that is generated automatically from the grammar for L. So in this very often we have this case as we have a programming language It's specified by context-free language, context-free grammar. This programming language is a deterministic context-free language, and we can generate a parser automatically from the grammar. Okay, so now I want to talk a little bit about a summary. So we have basically four kinds of languages. We have regular languages, context-free languages, context-sensitive languages, and recursively enumerable languages. And then we also have some subcases. We have two important subcases of context-free languages, linear and deterministic context-free languages. And we have an important subcase of recursively enumerable languages, recursive languages. These are languages that are decidable in the sense that there is a computer program that can determine whether a given string is a member of that language or not. So we have these languages, and these languages have, in some cases, corresponding grammars. A regular language is accepted by a regular grammar. A context-free language is accepted by a context-free grammar. A linear language is accepted by a linear grammar, and a context-sensitive language is accepted by a context-sensitive grammar, and an RE language is accepted by a general grammar. And then we have, I shouldn't say accepted, they're generated by these grammars. And then we have various automata that can accept these languages. So we have NFAs, DFAs, NFAs with epsilon transitions. They all accept regular languages. Context-free languages are accepted by non-deterministic push-down automata. Deterministic context-free languages are accepted by deterministic push-down automata. And then context-sensitive languages are accepted by linear bounded automata, which we really won't talk about much. And RE languages can be accepted by Turing machines, and recursive languages can be decided by Turing machines. And so the parts in red are parts that we have not really discussed yet in much detail, and so we're going to be looking at these two kinds of languages, and of course we're going to be looking at Turing machines. That will be in our next topic. So this completes the topic of push-down automata and context-free languages. I hope you enjoyed the lectures.